So, Elon Musk just dropped what might be his biggest bombshell yet. And no, it's not about Mars this time. He's talking about building a city on the moon, using tech that sounds like it was ripped straight from a sci-fi novel. But the big question is he serious? Everything hinges on this one very specific phrase, a self-growing city. Now, it sounds kind of fuzzy on purpose, but trust me, it's a massive clue. It points to the absolute heart of the plan. A city built not by people, but by a massive, ever-expanding army of AI robots. So what do you think? Is this just more hype, or is there an actual serious plan behind the talk? Well, that's exactly what we're going to unpack. We're going to look past the headlines and dive into the real blueprint for how you'd turn this wild dream into a lunar reality. Okay, first things first. We gotta ask, what happened to Mars? For years, all we heard was Mars, Mars, Mars. So why the big pivot to the moon all of a sudden? The answer, it turns out, is just pure pragmatism. It's about shifting from a goal that might be impossible to one that's just, well, incredibly difficult. And when you look at it side by side like this, the logic just clicks, right? Building a base on the moon, while a huge challenge, is something we could maybe pull off in a decade. A city on Mars? You're looking at 20 years, best case, with a very real chance it just can't be done. But here's the real kicker: safety. From the moon, you can always come home. Mars? That was always designed to be a one-way trip. So, what is this really all about? If it's not just about planting a flag and making history, what's the real mission? It's about building a factory. And not just any factory. This one is plugged directly into the biggest, most expensive tech race happening on Earth right now. The race to build artificial intelligence. The grand plan is to build a factory on the moon to churn out satellites. But forget about the Starlink satellites you know. This factory would build something totally new: orbital data centers. We're talking about flying supercomputers in space, designed to train and run the next generation of AI. And the craziest part? They'd be built almost entirely from materials mined right there on the moon. Okay, that sounds absolutely insane, right? So how on Earth, or I guess how on the moon, do you even begin to build something that ambitious? Well, the entire vision stands on 6 core technologies. Think of them as the 6 pillars holding the whole thing up. Without them, none of this happens. Let's break them down one by one. First up, pillar number 1. This one tackles probably the biggest headache in all of space travel: getting things off a planet or a moon and into orbit. And the solution is not another rocket. It's a wild piece of tech called a mass driver. So what is a mass driver? Honestly, the best way to think of it is as a giant electromagnetic catapult or a railgun. You know that insane instant acceleration you get in a Tesla? Imagine that, but scaled up 1,000,000 times, built on a long track to literally fling cargo into space. No rockets, no fuel, just raw electromagnetic power. But why can you only do this on the moon? Well, the numbers here tell the whole story. To get off Earth, you have to hit a mind-bending 11.2 kilometers per second, and you're fighting our thick atmosphere the whole way. But on the moon, you have way less gravity and basically zero atmosphere. You only need to reach 2.38 kilometers per second. That huge difference is what makes a rocketless launch possible. All right, a giant space cannon is pretty cool. But that brings up a pretty obvious question. Who's going to build the thing? And the factory? And mine all the moon rocks? It's sure not going to be a handful of astronauts in clunky spacesuits. Nope, the entire construction crew will be an army of robots. And this is where that weird phrase from the beginning, a self-growing city, suddenly makes perfect sense. The idea is to get the robots to a point where they can basically replicate themselves. It's like taking a classic science fiction concept, the von Neumann probe, and making it real. They'll use lunar dirt to build more robots, and those new robots will help build the factory bigger, creating a fully automated, self-expanding operation. Okay, so we've got a plan for launching stuff off the moon and robots to build it all. But how do we get the first robots, the first supplies, and the first people to the moon to get it all started? Well, that brings us to pillar number 3, and it's one you've definitely heard of: Starship. Starship is the absolute workhorse here. It's the heavy lift vehicle that makes the whole enterprise possible. It's designed to be the first rocket of this size that's completely reusable, that can haul huge amounts of cargo, refuel in space, and land vertically on the moon. But, and this is a big but, let's be real, it's still a work in progress. We've seen some amazing test flights, but we've also seen, well, some pretty spectacular fireballs. So Starship is our ride. It gets the first crew there. Now what? Where do they live? You're not exactly going to pitch a tent. The solution here is actually pretty ingenious because you don't bring the habitat with you. You arrive inside of it. And just to give you a sense of scale here, because this is just mind-blowing, a single Starship, once it's landed and you empty it out, has the same amount of living and working space as the entire International Space Station. That's from just one ship. But a big metal can isn't very safe from radiation and micrometeorites, right? So how do you protect it? The plan is surprisingly simple and kind of low-tech. You land the Starship, and then you just bury it. You use the robots to pile up several meters of lunar soil, or regolith, right on top of it. That thick layer of dirt provides all the natural insulation and radiation shielding you need. All right, so your home base is now safely buried underground. Awesome. But now you need to start moving things around the surface. Materials, equipment, other robots. You basically need a fleet of trucks. And for this, the plan borrows from, you guessed it, another one of Elon's companies. Now, obviously, you're not just going to drive a Cybertruck off the lot and onto the moon, but the core concept, a tough, durable, powerful electric vehicle, is the perfect starting point. Imagine a specially modified, stripped-down version run entirely by Tesla's autonomous driving AI, just hauling materials back and forth 24/7, no driver needed. It's a massive leap beyond the little dune buggies the Apollo astronauts used. And that brings us to our sixth and final pillar. This is the one that powers everything else. A self-growing city, an army of robots, a giant electromagnetic launcher. All of this is going to need an absolutely astronomical amount of energy. And it's all got to come from the sun. To put this number in perspective for you, 100 gigawatts is about 1/5 of the entire electricity generation capacity of the United States. That's the yearly manufacturing goal for new solar panels. It's a staggering amount of power, and it's needed to run the factory, the mass driver, and the AI satellites themselves. So let's step back for a second. When you put all 6 of these pillars together, the space cannon, the self-building robots, the Starship ferry, the buried habitats, the robo-trucks, and a near infinite amount of solar energy, you end up with something much, much bigger than a moon base. You get the foundation for a completely new philosophy of how we make things. And this quote really gets to the heart of it all. This isn't just about building stuff in space. It's about creating what you could call a post-scarcity supply chain, a system where energy is basically free and labor is fully automated. The ultimate goal is to get to a point where the only thing limiting what we can create is our own imagination. So you see, this plan isn't really just about going to the moon. The moon is just the testing ground. It's a blueprint for a future where the cost of making almost anything drops to nearly zero. And that, of course, leaves us with a truly profound question to think about. In a world where technology can make almost anything possible, what should we choose to build?